Welcome back, developers. Today we're diving deep into Amazon Q, an essential tool for building robust applications on AWS. In the ever-evolving world of software development, staying ahead of the curve is crucial. That's where Amazon Q comes into play. This fully managed message queuing service is expertly designed to decouple and scale microservices, distributed systems, and serverless applications, making it a must-have in your developer toolkit. Whether you're a seasoned pro or a newcomer to the field, understanding Amazon Q will give you an edge. Imagine being able to send, store, and receive messages between software components at any volume, without losing a single one. How about not needing other services to be available? These are just a few of the many benefits Amazon Q offers. In a nutshell, Amazon Q is a fully managed message queuing service that enables you to decouple and scale microservices, distributed systems, and serverless applications. With Amazon Q, you can send, store, and receive messages between software components at any volume. This ability is the bedrock of Amazon Q's functionality, and it's what makes it such an indispensable tool for developers working with distributed systems, microservices, and serverless applications. To break this down a little, Amazon Q operates as a message queue service, a kind of digital post office where you can send and receive messages between different parts of your software. But unlike a traditional post office, Amazon Q never loses a message. It ensures that every piece of communication sent is delivered to the right component, even if other services aren't available. But how does Amazon Q manage this? Well, it uses a process called decoupling. In simple terms, decoupling is like breaking up a large, complex task into smaller, more manageable parts. By separating or decoupling your software components from each other, Amazon Q allows them to run and scale independently. This means that even if one part of your application is under heavy load or temporarily unavailable, the rest of your system can continue to function normally. Amazon Q also provides message storage. This means that once a message is sent, it's stored safely within the Amazon Q system until it's successfully received. This ensures that no messages are lost in transit, providing a reliable communication system for your applications. But it's not just about sending and storing messages. Amazon Q also enables you to receive messages at any volume, from a few per day to millions per second. This makes it incredibly versatile, able to handle anything from small projects to large-scale, high-traffic applications. And the best part, Amazon Q is designed to be highly available, durable, and scalable. It's built to withstand any situation, ensuring that your messages are always delivered no matter what. It can scale up or down based on your application's needs, providing a robust messaging solution that grows with you. In essence, Amazon Q provides a solid foundation for building reliable, scalable applications. It's not just a tool, it's a game changer for developers. It's designed to be highly available, durable, and scalable to suit your application's needs. Now let's take a closer look at some key features of Amazon Q. First, we have message durability. When we talk about message durability, we refer to the ability of a system to store messages securely and reliably, ensuring that no data is lost in the process. This is a critical aspect of any messaging system, especially in distributed environments where multiple components interact and rely on the messages they exchange. So how does Amazon Q achieve this high level of message durability? The secret lies in its robust architecture. Amazon Q stores messages redundantly across multiple servers and data centers. This means that each message you send is not just stored on a single server. Instead, it is replicated and stored in different locations. This redundancy is an effective countermeasure against data loss, as even if one server fails, the message is still safely stored elsewhere. But what about data centers? Well, Amazon Q takes this a step further. Not only are your messages stored across multiple servers, but these servers are also spread across different data centers. This geographical distribution provides an additional layer of protection against data loss. Even in the rare event of a whole data center going offline, your messages remain safe and accessible from other locations. It's also worth noting that this process is entirely managed by Amazon Q. You, as a developer, don't need to worry about the nitty-gritty of data replication or managing multiple servers. You just send your messages, and Amazon Q takes care of the rest, ensuring that your messages are always safe and available. This high level of message durability provided by Amazon Q is a game changer. It allows developers to build robust applications with the confidence that their messages are stored securely and reliably. No matter the volume of messages or the complexity of the system, Amazon Q's message durability feature ensures that your application's communication remains uninterrupted and efficient, ensuring that your messages are safe and always available. Next, we have Message Visibility Timeout. This is one of the key features that makes Amazon Q a powerful tool for developers. But what does Message Visibility Timeout mean? Well, let me break it down for you. When a message is received from a queue in Amazon Q, it isn't immediately deleted. Instead, it's hidden. This is where Message Visibility Timeout comes into play. The timeout period is the length of time that the message is hidden and is therefore invisible to other receiving components. This means that during this period, the message is not accessible for processing by other consumers from the same queue. Why is this important? Imagine you have a system where multiple components are pulling messages from the same queue. Without the visibility timeout, as soon as one component receives a message, it would disappear from the queue. If that component then crashes or for some reason can't process the message would be lost. However, with the visibility timeout, the message remains hidden in the queue for a set period. If the receiving component processes the message successfully, it can then delete it from the queue. But if something goes wrong, the message will become visible again after the timeout period, ready to be picked up by another component. This way, Amazon Q ensures that no message is lost in processing and every message gets the attention it deserves. It also allows for increased parallelism in processing as multiple consumers can process different messages from the same queue simultaneously. The length of the visibility timeout is flexible. You can set it anywhere from 0 seconds up to 12 hours, depending on the needs of your application. This flexibility gives you the power to control how your messages are processed and ensure that your systems are robust and resilient. In essence, message visibility timeout is like a safety net, ensuring that your messages are not lost in transit and that they are processed in a timely and orderly manner. This feature provides you with control over how your messages are processed. Scalability is another critical aspect of Amazon Q. It's a key attribute that sets it apart from other messaging services. This feature is all about expanding capacity to accommodate growth. It's about being able to handle increasing amounts of work in an efficient and cost-effective manner. But what does this mean in the context of Amazon Q? Well, Amazon Q is designed to handle any amount of throughput. It can process thousands of messages per second or even millions. It's built to manage the peaks and troughs of your application's workload. Whether you're dealing with a sudden influx of user requests or a quiet period of low activity, Amazon Q is ready to step up or scale back as needed. Now, you might be wondering, does this scalability come at the cost of performance? The answer is, absolutely not. Amazon Q maintains high performance levels irrespective of the workload. It ensures that your messages are processed quickly and efficiently without introducing any additional latency. This means your application remains responsive, even during periods of high traffic. So, how does this work in practice? Imagine you're running an online retail store. On an average day, your application handles a steady stream of purchases. But come Black Friday, the number of purchases skyrockets. With Amazon Q, you don't have to worry about your application being overwhelmed. It automatically scales to handle the increased load, ensuring that every purchase is processed without delay. Scalability is not just about handling growth, though. It's also about cost effectiveness. With Amazon Q, you only pay for what you use. If your workload decreases, your costs decrease as well. This pay-as-you-go model means you're not wasting resources or money on capacity you don't need. In essence, scalability is about flexibility and efficiency. It's about ensuring your application can handle all the challenges of a dynamic and unpredictable digital world. Amazon Q's scalability ensures it can adapt to your application's needs, regardless of workload size. It's a reliable, robust, and cost-effective solution for your message queuing needs. In summary, Amazon Q simplifies the development of distributed applications by providing a reliable, scalable, and cost-effective messaging service. It's a tool that's essential for any developer's toolbox, whether you're a seasoned pro or just starting out. We've delved into the basics of Amazon Q, exploring its key features such as message durability, message visibility timeout, and scalability. We've seen how Amazon Q ensures message durability by redundantly storing messages across multiple servers and data centers, providing you with the confidence that your messages are safe and always available. We've also discussed the importance of message visibility timeout, a feature that allows you to control the availability of messages to other receiving components. And let's not forget scalability, Amazon Q's ability to handle any amount of throughput without introducing additional latency, making it ideal for applications with fluctuating workloads. That's all for today's deep dive into Amazon Q. If you found this video helpful, don't forget to like, share, and subscribe for more content. And as always, happy coding.